Alright, today we're going to be going over the change of base rule of logarithms, which is really important when you have homework problems or worksheets or any problem where there's logarithms but the bases don't match. And you can't do a nice little rule like you've been taught, like the addition rule or the subtraction rule, right? Because the bases here have to be the same. And if the bases are different numbers, well then you can't use those rules. So you're in a bit of a bind. So first, if you don't know what these rules are, check the link down below in the description. I have a great video explaining all the rules and how to use them. If you don't know what logarithms are, check the description also. I have a video about explaining logarithms and their bases and how to think about them. But with that said, let's go on to the change of base, right? So the change of base rule lets me put logarithms in terms of another logarithm with a different base, right? So let's say log base 3 of 5, right? 3 is my growth rate, and my answer is my time period that I've been growing, right? So what power do I have to raise 3 to get 5? It looks pretty rough to solve this, but I can use the change of base rule to rewrite this as log base 10 over of 5 over log base 10 of 3. And you might say, well, why did I rewrite it like log base 10? Right? Where is that new value from? That's what the change of base rule allows us to do. It allows us to write an expression where we literally change the logarithm's base. And we can change it to any number. But why did I choose 10? Well, I chose 10 because oftentimes with these problems, you'll need to use a calculator to solve them. And most calculators will have a base 10 logarithm button where you can punch in values and get those answers, right? Where most calculators and most things don't have one where you can plug in both the base and the value. So you need to learn and use the change of base rule. Change of base rule also comes up in some algebra problems as well. But to define the change of base rule, generally, right? If we have a log with a base of a and a value of b, right? We can rewrite it as log base z of b over log base z of a, where z is any number. But like I said, you'll usually see it in one of two circumstances, right? The base will be either base 10 or base e. Now log base 10 we usually just write as log, right? And we assume that the base 10 is there. That's why if you're looking at a calculator, the base 10 log will usually just be written log with no base 10, right? So if we were taking log of 100, I'd assume that to be base 10, and I'd say, what power do I have to raise 10 to get 100? 2. 10 squared is 100, so my answer would be 2. The other common value is, other common base for this is e. And e is kind of like pi, right? It's a number that repeats on for infinity. It's about 2.71, and it goes on forever. And you'll commonly see it used as a base, right? So log of e. This will also have a different way of writing it, which is called ln, right? And ln just means the same as log e. It's just a different way of writing it. So we'd write log e of 5 as ln of 5, right? Log base e of 7 as ln of 7, right? If I wanted to solve a problem like this, I'd say, what is 5 times ln of e, right? Well, what power do I have to raise e to get e? 1. So my answer would be 5 times 1, or just 5, right? Now, for actually solving my problem. Now, you can use any base that you want for these logarithm problems. They don't really, you'll get the same answer. So I get in my calculator, I plug in log, I can write, of 5 divided by log of 3. I get my answer as 1.46, and boom, I just solved this problem without having to use anything crazy. I was able to just use a calculator and a simple rule, and I was able to bypass the restriction that I had from these problems where I had to have similar bases. The reason why I say this is, if we were to add this expression, right? Let's say log base 5 of 3 plus this, right? We couldn't use the addition rule on this, but we could evaluate these individually, right? Do what we did here. And so we'd have log 3 of log 5 plus log 5 of log 3, and be able to find our answer that way, right? We could just find these individual values, add them together, and get our answer, where we wouldn't normally be able to do that with the addition rule. And that is the power of the change of base rule. I hope you enjoyed, I hope you found it helpful, and I hope you have a great day. Thanks for watching.